along with the contents of unit number 1. So I am here to give some basics of particularly related to the specific products of the crude petroleum. Okay, so these products of the crude petroleum belongs to some specific properties which you might have studied. So if you recall the last class, in the last class, I think we have studied about particularly the various kinds of the distillation processes, correct? So in that distillation process, we have studied flash distillation, equilibrium distillation, okay, TBP apparatus, ASTM distillation. Okay, okay. So first of all, let me share the screen and just wait for 1 minute. Just let me share my screen. Okay. I hope screen is visible to you. Okay, so in the last class, what we have seen is about particularly, you can see here, that is distillation characteristics, how to make the crude assay analysis, distillation characteristics. Okay, then TBP, ASTM distillation cones. We have seen that the true boiling point apparatus is like a batch distillation, correct? And at American Society of Testing and Machine Distillation course follows single stage analysis. Okay, they are going to follow the single stage analysis, which is not a specific requirement for a particular industry based applications. Okay, so in this particular today's lecture, we are going to learn about particularly about TBP distillation setup. So see here, you can see this is a TBP distillation setup. So what does it consist of? It consists of a packed column, correct? Then the packed column is surrounded by means of jacket, okay, and it is attached through the three-way flask, okay, what we call as a distillation flask, and that three-way flask is surrounded by means of electrical heating. So we can vaporize that particular liquid, and the separation can be caused because of the true difference between their boiling points, right? So you can see at the top the thermometer is also attached, okay. At the top of the packed column, thermometer is attached, so what should be the temperature, and then it is also collected to the right side, okay, it is collected to the reflux from the top one. So whatever the reflux is there, that reflux is connected, cold water is supplied, hot water is removed from that, okay, to cool the vapors, and it is converted to the liquid, and whatever the liquid which is coming out from that condenser, again it is charged to the vacuum distillation connection. So here you can see that there is a particular vacuum distillation unit, or it is considered as atmospheric distillation unit, which is connected at this, and whatever the condensate is there, that condensate is collected in the graduated cylinder, which is at the right side of that particular packed column. So here we can see that this particular method, the true boiling point apparatus is like a simple distillation, not a simple distillation, like a batch distillation. So in batch distillation, we can increase the number of stages which can be available for that. And here the actual difference is based on the this particular content. So this is a still which consists of having a volume capacity of 2 liter. Then this is connected to the vacuum producing devices. Okay, so that is called as either a vacuum distillation, or it is considered as either atmospheric distillation. So in this atmospheric distillation, the pressure is normally maintained at atmospheric pressure, and when vacuum distillation is there, especially that is used for naphthenic base type of the fluids. Okay, naphthenic base, that is whose boiling point range is in the range of something 275 degrees Celsius to 300 degrees Celsius. So in this naphthenic base particular types of the fluids, the major thing what we need to display is our the setup, okay, is our the setup which is required to bring the particular temperature at down to this one. So various fractions which are available in that can be separated. So here the routine wise crude distillation test is carried out in the standard TBP apparatus, okay, especially that is called as a packed column type of apparatus, and it has some specific size, it has some specific packing material with a fixed volume of the reflux ratio. So high reflux ratios are not preferred here, that is reflux to vapor ratio, because high reflux ratio may result into the flooding. So lower rate may produce some imperfect fractionation. So if you ask me about the distillation rates, then the distillation rates occur at the rate of 1% per 2 minutes at atmospheric pressure. Even they may occur at 1% per 5 minutes under vacuum distillation. Okay, so the rate of distillation is 1% uh, per 2 minutes. You can say that is 0.5% per minute in atmospheric distillation and 1% in 5 minutes under vacuum distillation. Generally, vacuum is provided either to prevent thermal degradation of higher boiling stocks, because some of the crude petroleum fractions may have higher values, correct? It may be above the 350 degrees Celsius or more than that. In that it may cover up to 450 degrees Celsius, because this one. So this particular vacuum are going to reduces the boiling point of the fractions, and for every pressure there is a definite boiling point. Okay, so for every pressure there is definite boiling point. So we need to prepare the chart for that. What is the boiling point for a particular pressure across this? So that's why initially we must know what is the true boiling point distillations for that, and in true boiling point of that particular mixture, once it is known, we are able to find what should be the uh, boiling point for any particular fractions that can be applicable. So after that, we are going to plot the vapor temperature versus the cumulative volume what has been vaporized. So we know the rate of vaporization for both the kinds of the distillation, because initially in the packed column section we perform atmospheric distillation, and again the reflux distillate which is going to come from that is again charged to the vacuum distillation of that. Okay, so here you can see that as the vapor temperature goes on increasing, okay, the volume of vaporization, okay, the volume percent of vaporization also goes on increasing, and at a particular volume it is going to remain a vertical line, it is going to remain the constant across this. So here you can see in that particular figure that almost particularly 50 minutes, okay, the 50 minutes or 50% of the volume is vaporized itself in atmospheric distillation. So you can imagine that how much is the percent efficiency for atmospheric distillation as compared to the vacuum distillation, and almost 30% is only vaporized in case of the vapor temperatures. So that is in case of at vacuum distillation with respect to the vapor temperature. So these are what we call as the TBP distillation analysis, or these are called the true boiling point curves, which are applicable in particular synthesis of that. So just to let me know you particularly about atmospheric distillation. So this was about atmospheric distillation, which was carried between 0 to 1040. Okay, only 50% exactly, or you can say 49% of that. Vacuum distillation almost has in the range of 39%, which can be applicable up to that particular range. Okay, so this was regarding particularly the true boiling point apparatus or TBP distillation. So this is a most commonly employed technique for especially with the fluid flow distillations columns, and I hope you have understood this. Okay, if you have any questions, you can put into the as a comments. Okay, whenever the comments have been asked, it will be give notification to me on the YouTube channel, and according to that I will answer with that particular questions. Now we will go most to the next apparatus. Now here you can see the ASTM distillation D86. See D86, there are certain kinds of methods which are standardized as per ASTM distillation, because if you are preparing any related to the product related to petrol, diesel or biodiesel, so there are certain standard process, okay, which are reported to characterize this, means determination of flash point, fire point,